Hello and welcome to the week 2 lesson for geometry around the world. This is Miss Oric, and this week we are going to talk about symmetry, fractals, and tessellations. So what are fractals? Fractals are geometric figures just like rectangles, circles, and squares, but fractals have special properties that those figures do not have. Fractals are never-ending patterns that repeat themselves at different scales. They can repeat and get smaller and smaller or larger and larger. Fractals found in nature, our galaxy, and even the human body. So if you look over here, these are fractals. Human body, okay? Our lungs right there. Here we have it in nature. I'm sorry, in a picture and stop. Hello and welcome to week 2 of Geometry Around the World. This is Miss Oric, and this week we are going to discuss symmetry, fractals, and tessellations. So what exactly are fractals? Well, fractals are geometric figures just like rectangles, circles, and squares, but fractals have special properties that those figures do not have. Fractals are never-ending patterns that repeat themselves at different scales. They can repeat and get smaller and smaller or larger and larger. Fractals are found in nature, our galaxy, and even the human body. So here's an example of the human body. Those are our lungs there. Fractals, as you can see. Okay, there's our patterns. And here in a piece of art. Okay, it also, if you look at it, reminds you of maybe something from our solar system too. So proof that fractals are found in lots of different places. So let's learn a little more about fractals. Nature has been creating fractals for years. There are 3 types we will take a look at. There's spiral fractals, which continuously widen and curve around the center, such as ones found in our galaxy. Branching fractals continuously divide as they grow, such as with the branching tree or with the human respiratory system, which we saw in the other slide. And then we have what's called radiating fractals. And radiating fractals have patterns that continuously spread out from the center, such as in some types of flowers. So here is a fractal fact sheet. And it has some of the images that we saw before, but here it shows nature. Here are some of our fractals here. If I can slide down. Here as well, and in math. Probably didn't think of that, right? And it goes into explaining examples. So natural fractals include branching patterns like trees, rivers, lightning bolts, blood vessels, and spiral patterns like seashells, hurricanes, and galaxies. So that really covers a wide variety of places where you would find fractals. And then they talk about math, okay? And there are mathematical fractals. And then there are certain fractals that are infinitely complex, and meaning that they can zoom and go on forever and ever without end. So just to give you a little idea, fractals are found in lots of different places, such as the human body, nature, and even our galaxy. Okay, so let's get out of this. So we're going to talk about symmetry. So what is symmetry? Now there is a video here that you can look at, but basically symmetry means that the sides are equal. They're mirror images of each other. So the heart is, or this picture of a heart is an example, because if you were to fold it down the middle in half, the sides would line up equally. So that means it has symmetry. Okay? And when you do go through this slideshow, click on this video, and that will open up and go into a little more about symmetry and how that works. Basically, as I said, a line of symmetry is an imaginary line that can be drawn throughout an object where one side is a perfect reflection or a mirror image of the other side. So here are some examples of different geometric shapes. If we were to draw a line here and fold it in half, it would fold evenly. So would this one. So would this one, and this one. Okay? So what you want to do is you want to think of a line of symmetry as a line in which you can fold the image in half. Okay, and if both sides line up evenly, then it's a line of symmetry. Now, let's talk about tessellations. Tessellations are a little bit different. They are patterns, they are involved, but what exactly are they? Well, tessellations are a pattern of shapes that fit perfectly together. Think of a jigsaw puzzle or a puzzle that you're putting together. The pieces at some point have to fit and lock in so that they eventually create one image. That's kind of what a tessellation is. And an example is just like the tiles on a floor, we create patterns of flat shapes to completely cover the surface. Okay, here are some simple tessellations, some examples here, and some more, but in color. And then we have tessellations in architecture, different buildings. Here's some tiling, it looks like that might be on a floor, okay? Could even be tiling on a roof. But architectural designs, very intricate designs, have also tessellations. And then quilts or blankets. People that make quilts and put them together end up doing a lot of different patterns that involve tessellations. Okay, here are some more in some artwork. So this gives you an idea of what tessellations are and how they can be found in a lot of different places as well. Okay, so for our slideshow this week, that pretty much concludes what tessellations are, what symmetry is, and what fractals are. So geometry is a lot more than just shapes and sides and rays and lines, but it actually involves images, symmetry, things that are found in art, architecture, nature, the human body, and it's a lot bigger. Geometry is a lot bigger and broader than we realize. So hopefully that gives you a little idea about what symmetry and fractals and tessellations are, and opens your mind to the possibilities of different things being out there when you look at things in nature, or maybe the next time you're taking a walk somewhere, or you're in a building, or even shopping somewhere, and if you see some type of tiling on a wall, it may make you think of, oh gee, that's a tessellation, or that looks like a fractal if you're out somewhere and you happen to see a certain type of flower and some patterns in it. So hopefully this will give you an idea of different things that you can look out for, and will also help you with this week's work. So that concludes our lesson for week 2. If you need to replay this, you can replay it at any time. And if you have any questions, feel free to reach out to me. Thank you, and I will talk to you later.